I have been wanting to do this video for some time now, and now that I finally got around to it, what we're going to do here is talk about the differences between hardware versus a software calibrated display. I know that many of you have watched the calibration videos on my channel, and it may answer some of your questions about what the differences between a hardware versus software calibrated display is, but it never really go out and just talk about these topics specifically. So what I'm going to do here is just that, comparing the two together, explain to you what are the differences and the process that it has to go through and so forth, and demystifying a lot of concept along the way too. I'm Art, and Art is right. Before we start, subscribe if you're new and hit on the bell icon so you'll be notified every time I upload cool new videos like this. To give us some context and background, majority of the displays that we see out there, the standalone ones that you see in bank and offices, are generally going to be a software calibrated display. This would include any type of display built into your laptop, all-in-one desktop PC, iMac Pro. All these are software calibration. And this includes BenQ PD Pro line displays too. This is part of their Pro designer display lineup. This is the 3220U. It is a 32-inch 4K display, and it is also software calibration. The other type of displays that are out there is a hardware calibrated display, such as this one right here, the BenQ SW270C. This is a hardware calibrated display, including BenQ entire SW line and also the PV line that have been discontinued are hardware calibrated display. So before we talk about the differences between software and hardware calibration, let's give us some history. So back then, before BenQ entered the market, there's really two brands of hardware calibrated display for photographers. One of them is AZO, the other one is NEZ. AZO today still commands the highest price point and is still known to be one of the best. NEZ is still around today, although I don't believe they're releasing any new displays at the moment. I think that for the most part, they're just maintaining the status quo of the models that they have. So that's my understanding of NEZ. And then in 2015, BenQ have released the SW2700PT, a hardware calibrated display that is one of the best-selling models because it is a photographer display, it is hardware calibration capable, and the price point is just fantastic. Never before have we seen that. So BenQ have gone in and changed the market in a couple different ways. Number one, they broke the duopoly between AZO and NEZ for hardware calibrated display. The other thing too is that they also have paved way for other display manufacturers to come into this market. So now, if you really count the number of display manufacturers out there that are making pro hardware calibrated display for photographers, you're really probably talking about maybe about less than two handfuls of display manufacturers. So we're still talking about in the single digits, but there are much more competition out there now, and there are a lot more choices for us to choose. So you really have to thank BenQ for that. And I'm really happy that they have come into the market, because the honest answer is this. The hardware calibrated displays that were available before BenQ came to the market were great, but the price point that they have to offer is just really out of my price range. I'd rather use that money to buy a new camera and more lenses to use in my arsenal rather than getting a display like that to do a color critical workflow. But what BenQ have done is brought the price point of the display down so much that I can afford to have multiple of these in my studios. In fact, on my main desk I have a triple display set up, and I have three of their 27-inch display working in tandem together, and all of them are hardware calibrated display. So what's great is that now we can afford to buy not just only one. If we need more than one, we can buy multiple of them and use in our entire setup. So that is what happens. BenQ broke duopoly. A lot of other companies have come in to this hardware calibrated display market. So now that we have discussed that a little bit and we have some ideas, if you take a look at these display in general, with the difference between the software versus a hardware calibrated display, you really can't tell the difference unless you see the model number and you know exactly what you're getting. So what's really the differences between these two? I can tell you, like in my previous video, that on a hardware calibrated display, there is a computer and a chip. And I would kind of be lying to you a little bit, because there is a computer and a chip in all these software calibrated display too. You're going to need a circuit board and a chip inside the display regardless, because it's not just the panel there. There's always a computer in the background. But the difference is this, where the hardware calibrated display has a 3D lookup table, and this 3D lookup table can be adjusted with the manufacturer software. So for instance, with the BenQ display, you'll be using Palette Master Element with the SW line and Palette Master with the PV line display to do a true hardware calibration on this. That means all the color adjustment is actually done at the panel level compared to a software calibrated display where there is a LUT on here too, but the LUT on these display is fixed and it cannot be adjusted or changed once it's calibrated from the factory. On a software calibrated display, you would need an external device to do the calibration, such as a colorimeter or a color spectrophotometer. On majority of the hardware calibrated display out there in the market right now, you would need to own one of these external devices to run a calibration on them too. The exception being that on the very high-end hardware calibrated display, it would come with their own calibrator built in, which is a good and a bad thing because if you really think about it, you're paying for that high-end display, but you're also paying for the price of that built-in calibrator too. And that calibrator will only calibrate that display. You cannot take that calibrator out and calibrate your laptop or your iMac, whatever other devices, whatever display you have is stuck to that device. And the moment that display goes bad, if you have to throw away that display, you also throw away the calibrator. So having another calibration device that's external to the display itself, I think is really useful because it gives you extensibility where you can take this device and calibrate any displays that you have. Now that we have talked about the calibration devices, let's talk about what happens during the calibration. We're going to start with the software calibration, which is going to be our baseline. So when you run a calibration on the software calibrated display, whether it be this PD line or on your laptop, whatever that may be, the colors is flashing. The program knows exactly what color is supposed to be, and essentially the color is flashing. The device is measuring what color is actually showing. So between the difference of the reference value, what's supposed to be, and the measured value, the software calibration program would then generate an ICC profile. This ICC profile is going to contain a few information, and it's going to change and manipulate and remap the color output from the video card to show properly on the display. But because it is doing that signal remapping, signal manipulations, and so forth, this causes sometimes tonal compression and tonal expansion in order for the color range to fit. And if you have done color correction in Photoshop, you will find out really quickly that the moment you change one color, it affects the other color too. And this is something very similar that's happening with software calibration with the ICC profile, is that the moment the program go in and adjust one colors, other colors are going to start to change accordingly too. So it will only be able to do so much. It's still really great though, and I still recommend going to calibrate your display. However, there is going to be a limitation to a software calibrated display. So now that we have a baseline of how software calibration works, let's talk about a hardware calibrated display. The measurement process is very similar, meaning that it will also flash different colors, different values. The program that you're using know exactly what those references values are and is going to do the adjustment to change those colors or remap those colors to fit. The difference is that rather than having an ICC profile that is changing the video card output and the color output from the video card, all the color adjustment is happening on the display itself on a dedicated chip. So this means that your video card is allowed to output the colors at 100% in RGB channel, so there is no tonal compression whatsoever. Ultimately, what this really comes down to is that when you really work with a high dynamic range file or like something that has a lot of information, you're going to see less of a banding and posterization from the signal itself on these hardware calibrated display compared to a software calibrated ones. And one more thing about a hardware calibrated display is that there is still an ICC profile that will sit on your system. So what that ICC profile does is that it contains the RGB color gamut information, whether you have calibrated your display in panel native, Adobe RGB, sRGB, it's pretty much telling the video card what RGB color gamut to output that signal to the display. And the best thing to do is to match the ICC profile to the calibration that you have on the display. The difference between the ICC profile on a hardware calibrated display is that there is no color remapping in the file versus the one on a software calibrated display. There's one more difference between a software versus a hardware calibrated display, and I feel that this is the most important one. On these software calibrated displays, they're generally calibrated from the factory at either display P3 or DCI P3 color gamut. And if you have run a color calibration before on the software Calibrated display, in the software, there is really nowhere in there that you can go in and choose a different RGB primary. That is because the RGB primary has already been set from the factory and there is no way to change it. These displays, and many of the displays out there, will come with preset color modes from the factory. And if they have been calibrated at display P3 or DCI P3, going to any color space smaller than that, such as Rec 709, sRGB, you're okay. The problem is that if you start to go into a different color space in general, such as Adobe RGB, well, the color is going to be based on DCI P3 or display P3 color space. On a hardware calibrated display, if you run a calibration using the manufacturer's software, you can generally choose the RGB primary that you want to calibrate it to. And because all the color adjustment is happening on the lookup table, a color that you see on the screen will match exactly to the color gamut that you have chosen. This would include any of the preset color modes that come with the display as well that have been calibrated from the factory. It will show true to that color gamut. So first of all, what I'm going to do is let's talk about a hardware calibrated display such as this one first, and I'm going to do this. Pull Adobe RGB in as a reference. So this is what a reference Adobe RGB looks like. I'll hold that for comparison. And let's do an Adobe RGB calibration with this one using Palette Master Element. We can see right then and there that the color is more saturated. What this means is that when you calibrate this to Adobe RGB, we're getting a slightly larger color space than Adobe RGB reference, which is really great. What's really amazing though is that if I calibrate my BenQ to panel native, you will see the color expand quite a bit there. So this is panel native compared to reference Adobe RGB, and for the most part, it's engulfing the Adobe RGB, so it can show much more color than Adobe RGB can, and this is really awesome. So then I got curious, and I've also run a software calibration on these hardware calibrated display using the factory preset calibrated color mode. So let's start out by pulling the Adobe RGB in first. This is calibrated using i1 Profiler software, and you can see there that even in Adobe RGB color mode, it engulfs it entirely. And I've also gone in and calibrated in different other color modes too, and you will see right away that the color wedge changes. For example, this is DCI P3, this is sRGB, which is something to be expected. But the fact that the color wedge changes according to the way how that color is supposed to look is actually a good sign. So now let's talk about the PD3220U, which I've actually run the calibration on. Again, let's pull up Adobe RGB. This is Adobe RGB. The wireframe that you see there is the reference, and the one inside there is the Adobe RGB on the PD3220U. Now, this is not necessarily a fair comparison because this display is never guaranteed to have 99% Adobe RGB, but we're just really using this to talk about the differences between a software versus a hardware calibrated display. So what I'm going to do now is hold this Adobe RGB calibration in Adobe RGB color mode for reference and pull in display P3. So we can see there that display P3 does engulf it, but what's really more amazing, let's hold that for comparison and pull Adobe RGB in, is that the colors that we're getting is really based on the display P3 RGB primary. If you can see the way how the wedge and the shapes are, is really much closer to display P3 rather than Adobe RGB. So this also tells us that on a software calibrated display, once they have been calibrated from the factory, there's really no way to change the color gamut. I've also gone in and do a couple of other colors too. For example, I've also gone in and do a display P3, and you can see that it matches really closely. This is an sRGB on there. So on an sRGB, let's hold this for comparison, and then we'll pull in the sRGB reference in. So again, the sRGB is really close because it is a smaller color space that fit within display P3. But if you try to go to another color space that doesn't really match with display P3 anymore, a software calibrated display is going to start to show its limitation really quickly compared to a hardware calibrated one. And if you're a photographer and you definitely want to work in Adobe RGB or larger than Adobe RGB, but have the color wedge close to Adobe RGB, a hardware calibrated display is probably the one to go with. So we have just covered a lot of technical information, but I feel that that foundation is going to be important for what we're about to discuss next, and that is the real-world usage. Well, I see a difference between a software versus a hardware calibrated display. So the short answer to that is it really depends. On a lower end software calibrated display, the difference is going to be night and day. If you talk about a higher end software calibrated display, such as the BenQ PD line, the differences are going to be smaller, but there is going to be a differences. The best way how I can say this is that on a software calibrated display, it will get you 80% of the time there, very similar to a hardware calibrated display, but that extra 20% at the end is going to be difficult to achieve on some of these displays, not all of them, just on some of them. But with these ones, you're going to be able to achieve that 90 to 100 level much faster than on these displays, because, for instance, if you have a picture with a lot of tonal transition, a lot of gradations from white to gray, white to black, and so forth, a hardware calibrated display is going to do a much better job transitioning those tones, because the signal output, the ICC profile, there is no color remapping whatsoever compared to a software calibrated display. So that fundamental alone is going to change the way how the colors and gradations are going to show on the display when we're discussing here. And I know that when we talk about color and gradation, we can also talk about the bit depth, but that's not part of the discussion here. The discussion here is really about calibration. So there's a few more things I like to discuss about these hardware calibrated displays. And number one is that the whole experience is not as simple as just buying the display, plugging in and using it. You can do it that way. However, for the best result, you should go in and calibrate your display. The thing is that BenQ brought the price of these hardware calibrated displays to the reasonable amount that many of us can now afford to get a really great high-end display like this. But the thing is that this also happens to be the first time we're buying a hardware calibrated display. And secondly, it's also the first time many of us have to go through a calibration process. So this creates a lot of doubt, because what we have been using so far, these software calibrated displays and the one built into your laptop and so forth, they render color in a particular way that we're used to, and we're used to seeing it. So the moment we calibrate this display, the validation pass, but we now have doubts, because when we pull in the picture, it doesn't really look the same way as we are expecting. So what's really going on there? Well, I think that when you start to get into a high-end display, you really need to start to see things a little differently and kind of recalibrate your eyes in a way that what you're used to is not necessarily what is correct. This is now the correct reference of what you should be looking at. And if you pull in your pictures and they don't look as good, well, I wouldn't necessarily go in and readjust those pictures. But going forward, what I would do is push your picture further, because what these displays really show you is that the level of editing that you're doing, and that you can push your editing, your photo editing much further for it to pop on these displays. The thing is that if a picture looks great on these hardware calibrated display, they'll look amazing on any other display. It's very easy for a picture to look great on a software calibrated display, because the best analogy that I can give you is that walk into any TV stores. You walk in there, you see bright displays with full saturated colors. And that's because they want to grab your attention. That's a very similar philosophy for any of the other software calibrated displays out there, is that they want to go for that saturation, because most of these are being sold to consumers. And the thing is that with these displays, you're going to see true accurate colors, but true accurate colors may not necessarily reflect the same way as on these displays that are calibrated to DCI P3 or display P3. So now that we're approaching the end, there's a few more thoughts that I'd like to wrap this up. Having a hardware calibrated display is great too, especially if you're trying to run multiple displays on your system. And the reason why is because generally, when you plug in multiple displays, your video card will only allow you to output one LUT. It doesn't matter how many color profiles you can set. You can set many color profiles, but your video card's really only outputting one lookup table. The great thing about these hardware calibrated displays is that the lookup table is stored on here, so it doesn't really care what the video card outlook table is doing. And this is different than a software calibrated display, where even if you have multiple displays, you have gone in and calibrate all of them. All the displays are running based on one singular LUT coming out of the system, with the exception being Apple devices with a built-in display. Based on some conversation I have with some engineers, this apparently will output two LUTs, so one LUT for the built-in display and another LUT for the external display. But again, having a hardware calibrated display is going to help in this regard when you run the display in multiple system setup. And let's talk about the advantages and disadvantages. So much more accurate colors. The price point are going to be higher than a software calibrated display. On the software calibrated one, price point are generally lower. Calibration process, I say that if you are used to software calibration before, hardware calibration is going to be fairly easy. If you haven't done any display calibration before, there is a learning curve, and a software calibrated display may be a little bit easier for you to go in and really dial in the setting compared to a hardware calibrated display. So those are kind of the pro and cons of a system. But if you take a look at the BenQ SB line, the price now are just so reasonable that you can really just afford to get into these displays. So anyhow, that's my thought about the difference between software versus a hardware calibrated display. I hope that you find this information helpful. If you have any questions about this, leave them in the comment section below. Give this video a like, subscribe if you're new, hit on the bell to be notified every time I upload cool new contents like this. And until next time, ArtIsRight.